Yes. 14 and 15 and 14. Oh, 14's a good one.
Upper dog, baby. Upper dog. How about the Bengals?
All right, here we go. Because I'm multiplying inside the parentheses, I can distribute that exponent. That's the only reason when you multiply or divide, not when you do anything else. So this would be 2 to the 5th, I to the 5th, times I to the 2nd. And then what is the square root of 6 squared? 6. Multiplication is commutative, so I can multiply in any order that I want. So 2 to the 5th is 2, 4, 8, 16, 32. Oh, it was a joke. It was a joke. Okay. 32. I do, but mine's not doing that. I don't know. I don't know. All right, 32 times 6. What's 32 times 6? I to the 7th becomes what? 4 goes into 7. How'd you get that?
Because I did the little thing.
All right, so you divide it by 4, and the remainder tells you which iteration you use, right? So if it's a remainder of 1, that's I, right? Remainder of 2, -1. Remainder of 3, -I. Whoa. And remainder of 4, 1. So I to the 7th, 4 goes into 4 goes into 7 one time, and what's the remainder when you divide it by 4? 0.75 or 3. That's exactly right. If you're doing decimals, this would be 0.25, 0.5, 0.75, 0. Memorize those 4. Yeah, memorize those 4. So this would be this scenario. So I replace the I to the 7th with -I. So this becomes -192I. -1. Yeah. Did you watch the recording from Friday?
No, I got home at 11 last night.
Go back and watch that. Go back and watch it. It'll help. All right. How about which other one did you say? 15? 15 and 20. X squared plus 4 equals 0. I'm going to sad map because the x is only in there one time. So x squared equals -4. If I take the square root on both sides, what's the square root of -4? I, and then the square root of 4 is 2. So I get 2I. Basically, Kate, to summarize, if you have a negative under a radical, you drop the negative and you put an I outside. Yep. See how I had a negative here? I just dropped the negative off and put an I outside. And then keep doing everything the way I've been doing. What did you say, Charlie, that was relevant? It goes in front of every radical but behind numbers, like whole numbers. So that's why the I is behind it too. If it was something like this, where it broke down, I'd have I root 50. I could do 25 and 2, right? Square root of 25 is 5, so now the I would go behind the 5 but in front of the radical. Yeah. And then you said 20? Ooh, okay, this one's for you. I hope you're writing these down on your paper as we go. -4/3 x squared minus 15 equals 201. What do I do first? Plus 15. -4/3 x squared equals 216. What now? Multiply by the reciprocal. That's exactly right. I'm going to multiply by negative 3/4. So x squared equals, what does that give you? Come on, y'all. Thank you. I thought you said I have no clue. You said 162. Did somebody say, or just say? I don't know. Square root. Okay, look, what's wrong? What am I going to do? Tell me what I do first. This makes me have an I outside, and I'm going to split it up. What's the biggest, you got a question?
If I did what I did was the same thing, but I multiplied by 3 on both sides, then
divided by 4, that's fine. Yeah, that's fine. What's the biggest perfect square I can take out of 162? 81 and what? And 2. So I get plus or minus 9i root 2. It's hard. It's mid. I was supposed to be today, but with all the stuff going on, I got confuzzled. It'll be tomorrow.
I'm getting my calculator.
All right. And what we did before and what we do today. Today builds, though.
no 11s.
All right, you ready? It's been a while since we had a quiz, hasn't it? Yeah, y'all. I was trying to get you to shut up. Okay, complex numbers. So far, we've talked about imaginary. Well, we talked about real numbers because that's what we talked about to start with anyway. Then we talked about imaginary numbers. Now we're talking about complex numbers. So complex numbers are just they're really easy. They are imaginary numbers that you either add or subtract a real number to, and you leave them just this way. So they look something like 2i plus 5. That is a complex number. It has two parts, imaginary part, real number part. When we write it in standard form, this is the way we write it. The imaginary comes first, the real number comes second. It has an I on it. The I on it makes it imaginary. You gotta learn this. All right. Another example. What? Say that again. Probably not. Teaches you to be a problem solver. All right. Cade, you have so much to say on this subject. Give me another example of a complex number.
Complex number. 5i.
You are correct.
Let's go.
Is that a complex number?
No.
Why?
Because it doesn't have anything in it.
It doesn't have the real number part, right? It's got to have both. So y'all see the difference? You see what we're doing? This is going to be really easy for you, I hope, anyway. We're going to do all the operations with complex numbers. Add, subtract, multiply, and divide, and then we will be done. That's today. All right. Adding and subtracting. Logan, give me a complex number. Oh no, I gave it to y'all wrong. This is opposite. This is opposite for standard form. You put the real number first. It doesn't really matter. It doesn't matter. 7 plus what did you say, Logan? What do you think you do? How do you put them together? Add what? Like terms. That's all you do. Combine like terms. Take the real number part, which is 2 and 7. Together that gives you 9. And then the imaginary part, which is 3i and 4i, and together that gives you... Do I need to do another one of those? Are y'all okay? You're not solving, you're just adding. That's like saying, how do you sub? You see what I'm saying? Okay, I said we're going to add, subtract, multiply, and divide. All right. Subtraction is pretty much the same thing, only. So give me a complex number. Yes, he does. Anyone in the world. I'm going to switch your I and your real number since I gave it to you wrong to start with. All right. Give me, Hannah, give me a complex number. Any complex number in the whole world. Sure. Plus or minus. All right, so now I'm subtracting. So remember when you subtract, I'm subtracting everything in parentheses. Some of you learn same change everything kind of situation. And you can do that. Or you can say, I just know that I need to subtract my real number parts. So 3 minus 13 is negative 10. And then 8i minus negative 7i. Okay, so if you like, distribute the minus and then combine like terms. Yes, subtraction. Yep. This is not. Multiply is not hard either. It doesn't get kind of hard until we get to division. Yes, no, maybe so. Sure. All right. So I'm going to skim on past that, and I'm going to spend a little bit more time on multiplication and division. How do we multiply complex numbers? Well, Delaney, give me a complex number. Any complex number. That's okay. I did it backwards too. Yeah. Give me a complex number while you're there.
14 and 21i.
Okay. So look, I'm in a situation where I'm going to have to FOIL. That's right. So let's just go through. Remember, I don't do a whole lot of FOIL. I do distribute. So take your first time. Wait. Oh, and distribute the 7 times 14.
Dude, are you serious? 14 times. Yo.
7.
How did you do that?
What? 7 belongs here.
No, you're right. I. Keep going, Kate. Come on. 5i times 14.
Really?
Same thing with the help word.
105.
All right. Now what? Were you on Quiz Bowl? Now what do I do? I've multiplied. Combine our like terms. Combine like terms. These are like terms. Before I do, I'm going to handle this so that I can combine it with what it needs. I've got an I squared, and anytime I see an I squared, what do I do with that? I squared is the same thing as what? -1. That's exactly right. So this actually becomes positive 105 without an I on it. Right, because that's what I squared does. I squared only changes the sign of the number and goes away. So now let's put the numbers together that go together first. 98 and 105 give me 203. And then in the middle, I have negative 147i and 60i. I'm trusting you. And I'm done. That's the answer. Kay told us that's what 98 and 105 equal.
How'd you get 60?
I don't know. Kay told me it was 60.
5 times 14 is 70.
Kay.
You idiot.
That's not nice. Which makes this what? What's it change this to?
Eat as good as dead.
Wait, where did we get 70?
That blonde magazine. Oh, bad.
All right, let's do another one. Okay, complex numbers. Complex numbers, give me one.
35.
And 35. Give me another one. Let's do minus.
Why do we have to like?
Because that's what keeps Kay paying attention, is if I keep telling him to give me a number.
But
Do it. Mark, set, go. How do you know? How do you know what you're doing?
Well, there's nothing in between it.
And so that's implied what? Multiplication. Mark, set, go.
oh,
Yeah, how about tonight?
No bueno. Don't look up until you've worked yours. I'm going to work it with you.
735.
Mode. Hit mode.
Got it. I made a 40 on
What's 23 times 35?
I'm smoking school pass right now. Dude, I got like 10 for every smoke. Oh, the power like what's made? 40. I made 30 out of 45. I thought I knew it. That's a 6. You say that every time. Really? Yeah. Oh, right.
Is that what y'all got? Yay! No. If you didn't go, it could be some of those multiplying of those big numbers that just. Okay, Logan's very jealous that Kate keeps coming up with complex numbers and he doesn't. So, Logan, give me uno más. Now I want you to multiply these two.
Oh, man.
You're fixing to try to make it hard, aren't you? I just needed one from you, not two. Multiply. Something crazy happens when you do this. We're talking crazy, crazy. What's zero? What happened?
What happened?
What happened?
How could you die on the field?
What are y'all talking about? What happened? I multiplied two complex numbers, y'all. I multiplied two complex numbers and I got what kind of number? What kind of number is that? I got. Okay, besides perfect square, that's a good observation. But a real number, right? All right. So look. Here's why. This is important, y'all. These are what we call complex conjugates. And when you multiply complex conjugates together, you always get a real number.
It's always going to be a negative I squared.
Yeah. And so this is going to come in very handy as we divide. We're going to lose you. Okay, so what are complex conjugates, first of all? These are complex conjugates. Tell me what you think that means to be a complex conjugate. That's exactly right. So will you grab that and say Miss McGee's room? Yeah. So if I had 2 plus 7i, what would the complex conjugate of that be? 2 minus 7i. The only thing that changes is the middle sign. That's it. Does that make sense? All right, so if you take a complex number and you change the sign in the middle only, that's a conjugate. And when you multiply conjugates, you just get a real number, no more i's. Yeah. Yes. No, it could start out being, it could be 7 minus 2i, and the complex conjugate of that would be 7 plus 2i. Okay. All right. Yes. No, because we got to divide. All right. Complex conjugates, do we all understand what they are and what they do? Okay, so here we go. When we divide, very last thing. Let me refresh you because an imaginary number is not a complex number. It is a part of a complex, but it is not a complex. So, review. If I have, actually, I'm going to divide this into 2 parts. I'm going to say divide by an imaginary because I'm not sure that we actually did it. If I divide by an imaginary, so let's say I have 7 over 5i. Tell me what's the problem? Why can't you divide that? What about the denominator? It's got not just a variable, but what an imaginary. But an imaginary is a radical, right? And I can't have a radical in the bottom. When I have a radical in the bottom, how do I get rid of it?
You multiply the top of the bottom by that.
That's exactly right. So if I'm dividing by an imaginary number, I'm going to multiply the top and bottom by I. Just I. You don't want it by 5, you just want it by I, and you want it in the top and the bottom. Why? What does the top become? 7I. What does the bottom become? Close. Now I no longer have a radical in the bottom, and I'm A-OK to proceed. Correct. Yeah. You would just change the I squared then to -1. This is the same thing as this. Right.
But I mean, well, what about the ones that
5I23. Look. Oh, whenever you got a complex in the bottom, I'm fixing to show you that. So, no. So this is dividing by an imaginary, right? Let's divide by a complex, because I think that's what Bella's getting to. So I told you to do it two different ways. So by complex. By an imaginary is super easy. But by a complex is a little bit more difficult. So let's say I had 4 over 3 plus 2I. We'll make it easy. Okay. Do you see the difference? This as opposed to 7 over 5I. Dividing by an imaginary and dividing by a complex. When you divide by a complex, I'm going to multiply the top and bottom by the complex conjugate of the bottom. What does that mean? Okay, so what am I multiplying top and bottom by here? But what I do to the top, I have to do to the bottom as well. So the top becomes 12 minus 8I, and the bottom, and if I do this correctly, all my I's are just going to poof, disappear, right? 9 minus 6I plus 6I minus 4I squared. -2. Now what? Okay. And then you have it. Too easy. Y'all ready?